Hello friends, myself Vivi. Today in this video I am going to discuss about Fourier transform. So first we will see the formula for Fourier transform and inverse Fourier transform, then I will go for the example. So here the Fourier transform is given by the formula f of s. So Fourier transform is denoted by f of s, which is equal to 1 upon square root of 2 into pi integration minus infinity to plus infinity f of x e to the power of isx into dx. Here the integration is with respect to x. Here the f of s is called Fourier transform of this function f of x. So also the inverse Fourier transform is given by f of x is equal to 1 upon square root of 2 pi integration minus infinity to plus infinity f of s into e to the power of minus isx into dx. Here f of x is called inverse Fourier transform of f of s, and here the integration is with respect to s. Now we will see one or two example based on the formula. Now we will take one example. Find Fourier transform of f of x is equal to 1 for mod of x less than a and 0 for mod of x greater than a. Solution. So before start with the example, we will see the definition of modulus. So mod of x less than a, it means x lies between plus a and minus a. So if I plot a real line from minus infinity to plus infinity, so here it is 0, here I will take some a, minus a and plus a. So this is mod of x less than a. So there is 0 minus a to plus a, and mod of x greater than a indicates the range a to infinity and minus infinity to minus a. So now we'll take the solution. First I will write the formula f of s is equal to 1 upon square root of 2 upon pi minus infinity to plus infinity f of x into e to the power of isx into dx. So therefore f of s is equal to 1 upon square root of 2 upon pi. So minus, so here mod of x less than a and mod of x greater than a, so it is having three ranges. The first range is minus infinity to minus a to plus a, and a to infinity. So between this range and between minus infinity to plus minus a and a to infinity, the function is given as, the value of function is given as 0, and between minus a to plus a, it is given as 1, that is mod of x less than a. So this is what, minus a to plus a, they have given f of x as 1 into e to the power of isx into dx. So therefore f of x is equal to 1 upon square root of 2 upon pi. So integration of e raised to isx is e raised to isx divided by I into s, between the limit minus a to plus a. F of s is equal to 1 upon square root of 2 pi, I will write as it is, into 1 upon I into s, I will write as it is, Now I will put upper as well as lower limit. So upper limit is a, it becomes e raised to RAS minus e to the power of minus RAS. So this is the required answer. Even we can simplify this one. So here what I do, so I will multiply this one by 2 and I will divide by 2. So f of s is equal to 2 upon square root of 2 upon pi I will write as it is, into 1 upon s also I will write as it is. So here I will write e raised to RAS minus e raised to minus RAS upon 2. So we know that sin theta is nothing but e raised to I theta minus e raised to minus I theta upon 2 into I. So therefore it indicates f of s is equal to, so that is here I can write this 2 as root 2 into root 2. So 2 root 2 and 1 root 2 get cancelled. So this become root 2 upon pi into, so this is nothing but sin a into s divided by s. So this is the required answer. So I will take one more example. Find the Fourier transform of f of x equal to 1 minus x square if mod of x less than or equal to 1, 0 if mod of x greater than 1. Solution: given f of x equal to 1 minus x square. So here mod of x less than or equal to 1, it means x lies between 1 and minus 1. So 0 for mod of x greater than 1. So again I will read the definition of Fourier transform, that is 1 upon square root of 2 upon pi integration minus infinity to plus infinity f of x into e to the power of Isx into dx. So f of s I will write as it is 1 upon square root of 2 upon pi. So this is, I will split this limit, and between minus 1 and plus 1 the function is 1 minus x square, and out of that range the value of function is 0, that is mod of x greater than 1. So here I will write minus 1 to plus 1 minus x square into e to the power of Isx into dx. So now I will apply here generalized Bapper's rule and I will integrate the function. So the first function is here algebraic and the second function is exponential. So this becomes u and this is what v. So we know that integration of u into v into dx is nothing but u v1 minus v1 is nothing but integration of v, derivative of u is u dash, v1 of integration is v2 plus derivative of u dash is u double dash, integration of v2 is v3 minus 1 up to infinity. So now I will apply generalized Bapper's rule to integrate this function. Therefore f of x equal to, so I will write here 1 upon square root of 2 upon pi as it is. So I will write first term 1 minus x square as it is. Integration of e raised to Isx is e raised to Isx upon I into s minus derivative of 1 minus x square is minus 2x. Integration of e raised to Isx is e raised to sx upon I square and s square. Here already we are having 1 I into s. So plus derivative of minus 2x is minus 2 integration of e raised to isx is e raised to isx upon I cube into s cube. So between the limit minus 1 to plus 1. So therefore f of x is equal to 1 upon square root of 2 upon pi. So I will simplify this one. 1 minus x square I will write as it is e raised to sx upon I into s. I will write as it is. So I square value is minus 1. So minus into minus plus, plus into minus, this is minus. So it will become 2x e raised to sx upon s square. So I cube is nothing but minus I. So and also we know that 1 upon I is nothing but minus I. So here 1 I cube is nothing but minus I. So minus into minus it become plus, and 1 upon I is nothing but minus. So again it will become minus 2i e raised to sx upon s cube between the limit minus 1 to plus 1. So once again I will explain this one. So I cube is nothing but minus I. So minus into minus become plus, and 1 upon I is nothing but minus I. So I have written this I to numerator. So therefore f of s is equal to 1 upon square root of 2 upon pi. So now I will put the upper limit. So upper limit is 1 here. 1 minus 1 square is 0. So this becomes 0 minus, here also I will put 1. So 2 e raised to is upon s square minus 2 into I e raised to is upon s cube minus lower limit. Here lower limit is minus 1 whole square is plus 1. So again this become 0 minus, if I put minus here, minus into minus it become plus 2 e to the power of minus is upon s square minus 2i e to the power of minus is upon s cube. So this is what lower limit. So now I will further simplify this one. F of s is equal to, so I will write this 1 upon square root of 2 upon pi as it is, minus 2 e to the power of is upon s square. Also I will write as it is minus 2i e to the power of is upon s cube, plus into minus 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 2 e to the power of minus is upon s square, minus into minus plus 2 into I e to the power of minus is upon s cube. So I will simplify this one. F of s is equal to 1 upon square root of 2 upon pi. So between first and third term, so common is here minus 2 upon s square. So remaining is here e raised to is plus e raised to minus is. So minus 2 upon s square I have taken common. So here again I will take minus 2i upon s cube as common. So here remaining is e raised to is minus e raised to minus is. So now f of s is equal to 1 upon square root of 2 upon pi. So here what I do, I will do a small adjustment. Here I will divide this one by 2, so it will become minus 4. I will multiply here by 2 and I will divide by 2. I have done this adjustment. Minus, again same, I will multiply and divide by 2. Now f of s is equal to 1 upon square root of 2 upon pi. So I will let this as it is, 4 upon s square e raised to is plus e raised to minus is upon 2 minus. So I will take this, so you have forgotten to write this 2. So I will take this I to denominator. So we know that 1 upon I is equal to minus I. So I becomes minus 1 upon. So if I want I will take this minus 2 LHS. It becomes I equal to minus 1 upon I. So it becomes positive 4 upon s cube e raised to is minus e raised to minus upon 2 into I. So we know that cos theta is nothing but e raised to I theta plus minus I theta upon 2 and sin theta is equal to e raised to I theta e raised to minus I theta upon 2 into I. So therefore f of s is equal to 1 upon square root of 2 upon pi minus 4 upon s square into cos s plus 4 upon s cube into sin s. So if we want further, we can simplify this one or we can stop here only. So this is the required answer. So in this video we have seen the definition of Fourier transform and we have seen what is modulus and we have solved two examples based on the definition of Fourier transform. So for more videos you can subscribe my channel Vittal Gonkar. Thank you.